All right, this next distribution I'm going to do is called the exponential distribution. Exponential distribution. And exponential distributions are usually used for items that fail over. It's like you buy, in this example here, it's an LED. And so the idea is that if I plot the probability density function of this LED, it's going to look something like this, where f of x is the probability, x is the age of the LED, and this is probability of failure. And so the probability that something fails right away is much higher than something that it fails later on. And so basically what it means is that if you get all the way to the end, you know, you have to integrate the curve, right? So if you say, like, what's the probability that, you know, my LED is going to fail before 20 years, you would integrate this whole curve. And so the probability that something's going to make it out to like 40 years is slim to none. There's no way it's going to make it out that long because the LED is going to fail before then. Okay? So the probability distribution function is lambda e to the minus lambda x. And in this case, you have to sort of integrate this curve to get all of your probabilities and everything like that. But the nice thing is that they've done that for you. And so the probability, I say they, I mean the people in this textbook. The probability of that x is less than or equal to a is equal to 1 minus e to the negative lambda a. So if I want to know the probability that my LED is going to make it at least to 20 years, I just use this equation here. And so what do all these variables mean? So lambda is, that's a great question. What is lambda? Okay, mu, the mean, is 1 divided by lambda. And what's interesting about this distribution is that sigma is also 1 over lambda. So if they give you the mean, you can compute lambda. And so let's do an example problem here just to kind of highlight how this all works out. I'm going to move this up here. So mu is 1 over lambda, and then sigma is 1 over lambda. Okay, so this example problem here, this is example 6.13, says the length of life of an LED used in a digital instrument, blah, 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 has a mean life of 2,000 days, okay? So the mean life is 2,000 days, all right? So that means lambda is 1 over 2,000, right? Okay, they already told you what the mean was. It also says in the problem that the PDF is exponential, okay? Somebody has to tell you that there are some key, when you do these homework problems, there are key words in the problem, and the key words sort of dictate what distribution you need to know. Like if the variable is continuous, you're not going to use binomial. Well, actually, I think you can still do that. Let's scratch that. If they tell you that the distribution is, actually, you know, I say binomial. I mean, you have an event that, if you have an event that succeeds or fails, that's binomial, because it either succeeds or it fails. And then if you have something that says like it's an exponential distribution, then that's an exponential distribution. If somebody says, you know, in that last problem, you know, for the Poisson distribution, if somebody says, you know, in a binary data stream, there are 3 errors per minute, what's the probability that 0 errors per minute have? There are some key words that sort of dictate like which distribution that you use. And so in this case, they kind of need to tell you that the distribution is exponential. Okay? So then the question is find the probability that a given LED will fail within 1,000 days. Okay? So part A is failure within 1,000 days. Okay? But that means A is 1,000, right? I want to know, so the mean is probably here at 2,000 days, right? So I want to know the area under this curve right here at 1,000 days. And so that's probability that x is less than or equal to 1,000, right? The probability that my LED lasts anywhere less than or equal to 1,000 is equal to 1 minus e to the negative lambda a, which is 1 minus e to the negative, lambda is 1 over 2,000, a is 1,000, so that's e to the negative 1/2, okay? If I did that right. E to the minus 1/2 is that square root of 2.7, so it's like square root of 3 Square root of 3 is like, what, 1.3-ish? No, there's no way that's right. Yeah, okay. So then 1 divided by 1.3 is what? It's like 10 over 13, say like 0.6. So it's like 1 minus 0.6 is like 0.4. Okay? So there's your probability. Oh, it looks like I did that wrong. They say it's about 0.4. I can't do mental math, at least with decimals. All right? So 1 minus e to the negative 1/2, and then boom. Wait, no, I had it right the first time. Should have trusted my gut. 1 minus around 0.6 is around, yeah, they got 0.3935. Okay? And then there you go. So there's an example there of an exponential distribution. I hope you enjoyed this lecture. If you have any questions, post in the comments.